Well, good afternoon, everyone. I'd like to say thank you to Adam for introducing me. We are, at the moment, colleagues, but as you mentioned earlier, tonight we'll be rivals as Coventry play Sunderland in the semi-final. So didn't go our way the first time, but we'll see how we go on. First of all, before I start my presentation, I'd just like to invite Danny and Terry just to stand up or join me, whatever they want to do. This is actually, like Adam, this is the third presentation I've done here, and I've actually had a different job role at all three of them. So I am now an account manager along with the two gentlemen to my left. We just wanted to basically say if we haven't managed to catch all of you so far today, we just wanted to let you know sort of if you want to catch one of us, if we don't look after your area, we'll point you in the right direction. So I basically look after the left-hand side of the country, Wales and Ireland, and then I'll let you go.
Yeah, I look after in the north, so from Manchester, Leeds, up over, right up into Scotland.
If you split the country right down the middle from about here, I look after the east.
Yeah, so if anyone's got any questions for us or anything like that, just come and see us during the rest of the day, and we'll be happy to help. Like I said, if you're not sure, just speak to one of us or anyone with a PolyWorks t-shirt on, we can point you in the right direction. Thanks, guys.
Thanks, Ben.
Cool. I would also like to say welcome back this year to John Church, who is in the third row there. 2 years ago, my first presentation, I was told it was good to include some audience interaction, which ended up with me throwing something at John when he was in the front row. John didn't attend last year, so I'm glad to see he's come back this year. I've also been reminded by HR that because we're hardware neutral, if I throw something at one of our partners, I've got to throw something at all of them. So I've decided to leave it out this year. As you can see by the screen, my presentation is a continuation of Phil's earlier this morning, essentially what's new in PolyWorks 2025. I myself am specifically looking at more of the CNC CMM side, with a few caveats to that as well. If anyone's got any questions sort of at the end of the topic, feel free to answer, or again, come and find me at the end. The first caveat I've got though, however, is this is just something that we've been asked to include today. Those of you that have floating license keys for PolyWorks, essentially as of tomorrow, you're going to receive an email from us or Innovmetric, I'm not quite sure, to essentially say that the process of receiving those floating keys is changing. At the moment, you will receive an email from 3D scanners explaining the process of installing those keys and getting them activated and whatnot. As of tomorrow, you will be sent an email that looks something like this to let you know that from now on, as of sort of right now, I guess, or possibly tomorrow, floating keys are now available on my PolyWorks. So you'll be sent an email that looks like this to sort of explain how you can go about accessing them and so on. For those of you that don't know what My PolyWorks is, it's the online portal where you can go and access the software downloads, any macros for additional toolbars, or also tips and tricks, webinars, videos, that sort of thing. It's at this point that I mentioned that to access My PolyWorks, you do need to be under a PolyWorks support contract with 3D scanners. So if you're not sure if you are or not, again, come and find one of the three of us that have just stood up, and we can talk you through the process of sort of renewing that, or just to let you know whether you are or not. Moving on to my actual presentation, like I said, I'm going to be going through some improvements to the CNC CMM side of things. To start with a couple of improvements to the user interface, and then later on some functionalities as well. So starting off with the probe head orientation display. So in brackets, the picker tool, sort of a term for it, I guess. Those of you that aren't aware of it, essentially it's the arrow on the right-hand side and the buttons on the left. Once you're aligned to your CAD, you're then able to use the icon on the left to determine the tool angle based on where you are currently with your probe head and your orientation, your alignment, and so on. Essentially, there's been an improvement to the tool this year. At the moment, or previously, what you were able to do is actually click on the icon, hover over the CAD, and it would give you, as you can see, the orientation. Now, if it was a green arrow, that means it's already been calibrated and you can use it. Yellow would be it can be calibrated and you can use it, and red would mean it's just not possible. So I'm just going to show you essentially what's changed. Just before that, the reason for the change is that it's more to do with your sort of inferred heads and orientable probe heads. So for example, Revos, PHS2 and the like, essentially you're not just limited to certain angles, you've got infinite sort of angles that you can use. So the problem with this tool in the past is that for your sort of set angles, that was it. You would only be given so many. And the benefit of the orientable probe heads is that you can then essentially add further increments of angle to that as well. Okay, so like I said, the tool has now included additional functionalities to make sort of this a bit simpler and a bit more, give you more options essentially. And as I said, it works with orientable probe heads, but you'll also see benefits as well with laser scanners on the CMM and also star styli as well. So to show you how that works, if I just jump into Inspector, and then you'll see we have our card door here. So if you just bear with me a second while I connect. Start my first tool. Yeah, so you can see here, for example, we have an inferred head, and essentially, so I'm already aligned to this part. The pick and change orientation button is up here in your device toolbar. This allows me, as you can see, to hover over the model and essentially dictate what angle I'm going to change to. At the moment, it is just an arrow, but you will now see at the bottom of the 3D scene, there are some further tools that allow you to sort of improve the use of this tool, the sort of flexibility of it. So the first one I'm going to show you is actually the one in the middle. So at the moment, as you can see, it's just the arrow. If I do click the tool in the middle, you see the probe actually disappears in the head. What that allows you to do now is actually see the position of the probe head once you've made that calibration, that orientation change, sorry. So it's just a way to improve sort of your programming and essentially determine if there's going to be any collisions instead of just an arrow on the screen. You do have options for that. So for example, if I go into the options tab, you can see there that you've got a list of different sort of parts that you can display. So for example, if I choose the top one with the quill, you will see there that you also get that in the visual display as well. So again, it's just a way to improve essentially your programming and just ensure the safety of what's going on around it. So at the moment, if I just click, what it'll ask me to do is it'll ask me to create or calibrate or neither. So if I go to Don't Create and jump back in, the third tool is essentially pick and adjust. So like I said, the benefit of these sort of inferred heads, your Revos, your PHS2s, essentially you can have infinite angles. So at the moment, if I click, that's the angle that I'm given, so I can select that surface. But if I then scroll with the mouse wheel, you can see I can sort of swing it across sort of where I am to avoid any collisions, for example. You can either do that with the mouse wheel, you can do it with the slide bar at the bottom, or the plus and minus icons. You have some options available to essentially set a minimum step for adjustment and also restrict it to existing orientations as well. So just a bit of control over what you're doing. So if I just show you the other tools as well. So again, showing you the scanner, for example. So again, this one has a inferred head with a C angle on it. So if I just show you that we have a tool path, sort of just on the side here for the scan. Again, if I jump into pick and change, you can see there, look, that it, again, essentially the angle that it's at the minute is the sort of not what we want, because you want it to be perpendicular to the tool, to the scan path. So I can sort of roughly line it up, click, and then I can just control it with the mouse wheel and essentially put it in the orientation that you desire. And then the only one to show you is the star styli. And again, it's the same sort of principle. If I was looking at measuring one of these holes, for example, you can sort of click near it to get the orientation, and then again, you can scroll with the wheel to improve sort of usability. Does anyone have any questions on that before I move on? Nope. Cool. The next one is just a quick small topic. It shouldn't take too long. Essentially, so for example, there's two different ways in PolyWorks to create a go-to position, and the eagle-eyed amongst you might have noticed in the past that essentially there's one option to do this in the ribbon in your device tab, and there's also another way of doing it through your program, your sequence editor. You'll notice the biggest difference on there is there's a button missing on the left-hand side. So this button here is your read from device. So it will take wherever your head is at the moment, your probe, it will take those coordinates and stick them in either the XYZs or in your sequence for in the XYZs for your sequence. All they've done in 25 is they've just added that in essentially. So they've updated the interface ever so slightly, and they've also included the read from device button as well. The only difference that's still between the two is the tick box here at the bottom for your sequence editor version for allow optimization, because essentially that is designed specifically for the sequence to improve the efficiency of that CMM sequence. Again, the next few are quite sort of quick topics. You've got line scanner orientation creation for I++ CMM. In short, that's essentially just the ability to calibrate scanners on the UCC server for Runnashore. So moving on, just to show you sort of what it is. As Phil said earlier, some of this stuff has come from 24, so as you can see, this was introduced a few months back in 24 IR9. essentially what has happened is Renishaw have developed scanners for their CMMs. And because PolyWorks already has the integration of the CNC CMM calibration, Renishaw have essentially asked us to borrow that sort of information and then get us to do that for them. Those familiar with UCC at the moment will be aware that you need to do all of your tool calibrations, or your probe calibrations, sorry, in UCC, and then PolyWorks will then read that information in. Because of what I've just said, Renishaw have asked that PolyWorks do that for them. So essentially all of your scanning calibration is now done in PolyWorks for UCC. As it says at the bottom, this is only for laser scanners at the moment, and it's currently only for UCC for the I++ plugins. Whether that's limited to the future, I'm not sure. And just one other thing to mention that I think I've taken off the slide is that essentially you still need to jump back between UCC and PolyWorks for the windows to update. But in short, it's a much simpler process than it has been previously. One other quick topic, I mean, it's pretty straightforward, this one. Because of that change, there is now a minimum version of UCC that you will need to run with PolyWorks 2025. Essentially, without reading all that out, it's the bit at the bottom. So to be able to use PolyWorks 2025 with the UCC server, you need a minimum version of 5.10.1. So it might be worth making a note of that if you are looking to upgrade to 25. Okay. This topic I do have a video for, but I'm going to sort of leave it out because I'm going to essentially say if anyone's interested in it, I can show them at a later point, just because it's quite long. I might flick through it a couple of bits. Essentially, what Innovametric have introduced for 25 is the possibility of tactile scanning cross-sections and aerofoils using the 5-axis capabilities of the CMMs. So again, going back to My PolyWorks, in the macro zone tab, you're able to download different macros that have been created to essentially improve your day-to-day use of the software. On the right-hand side, you'll see the toolbar itself. So it is designed for the 5-axis capabilities, and you'll see second from the bottom, we've now got 5-axis cross-section scan. Like I said, just a reminder, My PolyWorks access does require a valid support contract, but if you just want access to that toolbar, we can send it to you as well, so just let us know. Like I said, I do have a video. I'm not going to play it because it's quite long, but I'm just going to talk about what it needs. So you'll see on the screen in a minute, we have a Revo with an aerofoil blade. Essentially, to get the tool to work, what you need to do is generate a cross-section, whether that's just a standard cross-section or an aerofoil gauge. And then from that, what you can do is create a polyline. So the way that it works is you use the polyline to generate your tool path, and then the cross-section is what's actually measured. So the dialog box that pops up, let's see if I can just find it briefly.
Just released is the Advanced CMM toolbar.
Okay, that's not going to work. So just to sort of show you what it looks like quickly. So you pick a polyline off the section, is what he's doing here, and then that is the, if you can see it very well on that screen, but essentially you have a box at the top that says what's your path, so you can measure that from the polyline, and then it's also further options of what you're actually being measured. So you measure the cross-section, and then you can extract the data from that. The only thing to add is you can actually pick a starting point for your polyline as well, which isn't always possible with just general polyline sort of measuring from that toolbar as well. I'm happy to send, like I said, I'm not going to play the whole thing because it's quite long, and I appreciate it's quite warm in here. So what I'm going to do is if anyone does have any questions about that, I'm happy to make the time to go through it with anyone if they want to see it and explain it, or after the event, of course. But essentially, yeah, it's just an added tool for your 5-axis CMMs. And not just limited to aerofoils as well. So you can do other things with it if necessary as well. So yeah, from the cross-section point of view, it just gives you a bit more, some extra tools at your disposal. Cool. Again, another sort of short topic, but I'll demo this in a second. It's a bit of a mouthful. Automatic adjustment algorithm on trim features. Probably make more sense in a minute when I show it. But essentially, it's now been introduced for planes, cylinders, and cones. And it essentially uses certain settings within your CNC measurement parameters to improve the efficiency of your programming. And as it says there at the bottom. So that's sort of what it does. I will show you a demo of it now, which will sort of make more sense. So yeah, automatic adjustment algorithm trim features. What I mean specifically by trim features, again, if you just allow me to connect quickly. So what I specifically mean by what I specifically mean by that is those that have used the CNC probing function before will know, for example, that at the top here we have quite a narrow plane. Now, normally what would happen is that you pick a plane on there, you go to CNC probe, and it will show you no measurement points because there is a setting within the CNC probing parameters that essentially is called boundary exclusion distance. So that will try and keep you away from edges or rads or chamfers or anything like that, or any actual features on that surface. That is defaulted to 3 millimeters. So if I sort of show you what it will do, so if I create a plane on that surface and then right click and you've got the option to CNC probe. Previously, that wouldn't have shown you any measurement points because the boundary exclusion distance just further down in your more options defaults to 3 millimeters. You will now see that it automatically works it out based on the size of the plane and the values that it can take from that. So in the instance of a plane, it just means that you now don't have to spend those extra few seconds tweaking that to sort of get that in. Obviously, you will still need to go in and tweak the amount of points if you've not set those by default and other settings like that as well. But that's the example with the planes. The example also works with, so from the slide previously, it spoke about sort of cylinders and cones as well. So for example, you'll see here that we have on the side, for example, we don't have a complete cylinder. As you see, it's, so that's what I sort of mean by trimmed. So when I go to create the cylinder or cone, you might have noticed there's a tick box here for trim using CAD surfaces. So if I just untick that for the moment to show you what it does, you can see that it's created the cylinder, but if I hide the CAD model, you'll see it's created a full cylinder based on the overall length that it was able to achieve. What you will see is that if I then still go to CNC probe, because it's not a trimmed surface, it will still try and access points that it can't access because it looks at the cylinder and not the CAD. Okay, so just to show you sort of, you can see where I'm going with it. So if I just redefine that cylinder, if I make sure I have trim using CAD surfaces turned on, just to prove the point that it is working, you'll see there that it trims it to the surface of the CAD. And then jumping back into the CNC probe measured function, you'll see there now that because it knows it's a trim feature, it automatically works out where your sort of measurement points could be. Again, same sort of principle, you will still need to go in and tweak number of points and so on, but it's just one of the things, sort of, I said one of the things, actually 4 things you don't need to worry about. So in the slide I said, so what it does is it automatically works out the max depth. It also changes your endpoint exclusion. So your endpoint is the distance from the top and the bottom. And then you've also got your start angle and angular range as well. So they're the 4 settings that have now been essentially automatically worked out for you. Just to essentially, again, improve your sort of speed of programming for the CMM. It also works with cones as well, but I hope you believe that as well. Moving on, so it's my penultimate topic, I believe. So again, a couple of slides and I'll show you a demonstration of how it works. So the optimization of the CNC linear scan path. Now previously what you'd have had to have done is if I wanted to scan a path and then scan back the other way, you'd have had to have created 2 paths, which is time consuming and why would you want to do that? So again, something that was introduced in actually early 2024, it's the ability to actually optimize an existing scan path. So if you've already created one, you now have tools available to essentially say reverse that direction in 2 different ways. The bit at the bottom, as again, it only works for, well, sorry, one thing to mention, it only works for linear paths and not areas. So I'll essentially show you where that option is in a second. But just an idea. So you'll see there that in your, so Phil sort of brought this up earlier, sort of, and he showed this image sort of, but on the right hand side, you'll see that there's now a tick box underneath where you generate your scanning paths to dictate where it starts from. And again, just a reminder that it's only for linear. So the second option is it's actually in your sequence as well. So I'll demonstrate in a minute how you get to both of these options and how it works. So again, it's just all designed on sort of trying to improve your sort of programming efficiency and cool again. So you see I'm already hopefully aligned to this, if you just bear with me. Just try to get my scanner in the right place. Perfect. Cool. So you don't have to record to be able to, so you don't have to have the well, you don't have to record to be able to do this, but I need this to show you where one of the tools are. So there's different ways of viewing it. Essentially what I'm going to start off by doing is if I go to scan, you can see here we've got our CMM scan path. So I'm just going to generate a path along the bottom, sort of left to right. So you see that I've got these control points where it's going to follow. And before I sort of confirm that, you'll see you can just about see it. There's like a blue line that comes from the scanner down to the first point to show the direction of travel for that first, sort of the direction it's going to take the points. So if I right click and confirm that, you can see here we now have the tick box available to say use closest start position, which in this case is actually not 0.1, it's 0.4 of the ones that I've done. So again, it's just a way to improve the speed of what you're doing. It's worth knowing as well that this tick box is either on or off for your entire sequence as well, which is why I'll show you there's another way of doing it. So you can either have it start from the closest point all the time or have it turned off, and you'll see there it does go back to position number 1. Cool, so if I now start scan, so we'll do our first scan path. And then like I said, if I wanted to then go back the other way, previously I'd have had to have recreated that scan path and just get it to do the opposite. Whereas now what I can do, what I might want to do, for example, is scan the other side of the sort of the lip there. So what I'm going to do is in my device tab, I'll just quickly change orientation. So you can see that from the, so we've just changed. And then if I hit resume scan, so in this case, use closest to start position makes no difference because number 1 is on the left-hand side anyway. So I can either leave it on or off in this instance. And you can see there, without the need for having to create another scan path, you can just go back and remeasure it from a different angle. And just to flick to the sequence editor, you can see that's putting it in as well. So going back to the slide, there was also another way of doing it from the sequence. So what I'm going to do is I'm just going to generate another path just to show you where you can do that from. So if I just close my scan a second, I'm just going to create another path. So again, one thing I did mention is this only for linear paths, so there is the option to create areas as well, but this will only work for linear. If I just generate a quick path across here, for example, so now we've got path 2. So in this case, I can again use closest start position, which in this case will do the same thing whether it's on or off. So we'll just generate those scan paths quickly. And then what I'm going to do, just to show you how it works in sequence, I'm just going to make sure it goes from the start in this case, just to show you there's another way of doing it, and just run it again. So it will go back to the first point and run it again. This is just so I can show you where the option is available in the sequence. So that's my scan done. And hopefully in the sequence we've created some steps. So you see here we've got, oh yeah. What I should have done there is change the orientation, so I'll show you on the first one anyway. But essentially now in your sequence step, you can see that if I double click, you have the option, sorry, not double click, click on the drop down. You will see now I now have the option to invert as well. So you don't need to do it from the scanning dialog box. The point of that is that, like I said, in the scanning dialog box, that will do the same thing for every single path. So whether you've got that on or off, that will do it for every single path. Unless in your sequence, you actually go into the individual steps and toggle that on or off. So you can sort of tweak it as you go along. Any questions? And then my final topic for this afternoon is this. So I don't know if any of you or all of you have been next door yet, but in the PolyWorks room on one of the 3D scanner stands, we have a Renishaw equator set up. Those of you that are unfamiliar, what is the Renishaw equator? So there's 2 different sizes to it. You've got the 300 on the left and the, I don't think it's so there's a 300 and a 500. I think both of these are 300s. There's just one that's sort of a, let's call it a 300 XL. What is the Renishaw equator? So first things first, just looking at the picture, it sort of looks like a mini CMM. It sort of is, but it isn't. So it isn't a CMM. It's a comparator sort of gauge designed for use on the shop floor to compare parts against each other. Like I said, it's designed for use on the shop floor and it's used to check trends. It has been supported in PolyWorks now for a while. The reason I'm bringing it up today is essentially there's now customer feedback of the sort of process of using it was quite varied. So what Innometric have done is they've improved the workflow and come up with 2. So you've got CMM Compare and Golden Compare. Again, available to download from my PolyWorks, and I'll go through those 2 workflows now. So these are in sort of zoomed in, you've got two workflows for it. So the way that the equator works is if you look at the left-hand side, you've got CMM Compare. The way that it works is if you do have a CMM and a CMM program, what you can do is run that program on a part. What the part mastering icon does on the left-hand side is that generates a calibration file for each feature that you measure in the CMM program. What you then do is you then take that calibration file to the equator, and then you can then run parts again and again and again. And you're not comparing back to the CMM, you're comparing back to the part itself, so you're looking at trends. The goal to compare workflow on the right-hand side requires no CMM. So the goal to compare is required for both workflows. CMM compare, you need both left and right. Goal to compare, you only need the right-hand side. So what goal to compare does is if you need a master sample, put that on the equator, it runs the same program as the CMM, you run it through, again, you generate some files, and then you just run a new piece like you normally would in Inspector. And what that does is it just compares repeatability of that process. So again, it isn't designed for the quality room, the quality lab, it's designed for the shop floor to just check trends, maybe the first of 50, the last of 50, for example, just to check the continuation of the process. So yeah, you're not looking at specific values, you're looking at trends, if that's the best way to explain it. And I've pinched this from the Unimetric presentation because it's essentially just showing you that you put a part on the CMM, run the part calibration file, you then move the part to the equator, run part mastering, so that takes all the information from the calibration files, and then you can just then run multiple pieces. So that's the CMM compare workflow, so that's the first part of it. If you don't have a CMM, you can just use the goal to compare, so I sort of can see it working now. So you lose the CMM, you put the master part on the equator, you then run the part mastering, so again, that generates some calibration files for the features that you measure. You remove that first part, and then again, you just press a new piece, which will then allow you to measure the rest of them. And again, just as the last thing to say, it's just it's to check trends, it's not to check results of the actual measurements of the features. Any questions? As I say, if anyone hasn't seen it, there is one next door that's running a program, so if you are interested, feel free to speak to me or go and speak to one of the guys that's looking after it next door. And that's everything from me. Like I said, if anyone's got any questions, just come and see one of us throughout the afternoon. Thank you for your time.